Looking back over latent heat just to get in a little bit more practice, we'll do a couple more calculations. Now, if you don't remember, your formula is Q equals ml. Q is your heat energy. That can be a positive value or a negative value. If it's positive, that means heat is absorbed. If it's negative, that means heat is released. It'll be measured in joules. You may also see it in kilojoules. M is a mass. It's going to be how much substance we have. Measured in grams can also be kilograms. And L is your latent heat value, your constant value. Each substance has its own unique latent heat value, but there's two of them. There's latent heat of fusion, which deals with solids to liquids, and there's latent heat of vaporization, which deals with liquids to gases, and both of those are reversible. So latent heat of fusion is also liquids to solids. Latent heat of vaporization is also gases to liquids. But the primary state of matter that you're dealing with is solids in fusion, gases in vaporization. And each substance will have those two values. And you can get those values from simple charts. I'm going to be using this chart I have on a Word document to reference some of these values when we do our problems. So our first problem says how much energy is needed to melt 1 kilogram of gold. So I know I'm doing latent heat. I know I'm not doing specific heat because there is no temperature, there's no temperature change. Latent heat only deals with the mass and the unique latent heat value. So it says how much energy, so I'm looking for Q. My mass is 1 kilogram. And 1 kilogram is, of course, 1,000 grams. And I'm dealing with gold. More specifically, I'm melting gold. Melting means fusion since it deals with solids. So I need to look at my chart. Gold fusion is 63 joules per gram. So 63 joules per gram. So when I get my answer will be in joules. And the mass I need to use is grams. So I'm going to use 1,000. So Q equals M times L. Q is X. I'm looking for it. M is 1,000. And the latent heat value is 63. 1,000 times 63 is 63,000. So it's going to take 63,000 joules of energy. All right, let's do another one. We got 10 kilojoules of energy was released when water froze. How much water was present? So this one's a little bit different. We're going to be looking for a mass. We're looking for how much water is there. So our energy is 10 kilojoules, which is 10,000 joules. My mass is what I'm looking for. My latent heat value is going to be for water. But which one? Fusion or vaporization? It froze. Froze means dealing with a solid. So we go to water fusion. Look at our chart. Water fusion is 334 joules per gram. So 334 joules per gram. So Q equals ml is our formula. Q, since my latent heat is in joules, I'm going to keep my Q in joules. So that's going to be 10,000 equals the mass, which I'm looking for. That's X. Latent heat constant is 334. So 10,000 stays 10,000. 334 times X is 334X. So divide by the value with X. 334 cancels. 334. So the mass is equal to 29.94 grams. And there's our answer. All right, next one. We got 8,800 joules of energy was absorbed to melt 100 grams of an unknown metal. What is the latent heat of the metal, and identify the metal. Okay, so let's set up our given information. Q is 8800. Our mass is 100 grams. And we're looking for that latent heat value. And this particular value will be fusion since it melted. Let's figure this out. So Q equals M times L. Q is 8800. My mass is 100. Latent heat value is X. That's what I'm looking for. So 8800 equals 100 times X. 100 times X is 100X. So I divide by 100 to get X by itself. 100 cancels out some zeros. So 88 is X. And we said it's the latent heat of fusion. So latent heat of fusion is 88 joules per gram. So there's the first answer for latent heat of metal. Next, we got to identify the metal. To do that, we need to reference a chart. So what is closest to 88 joules per gram? So let's go to our chart, look for whatever's closest to 88 joules per gram under heat of fusion, and we get to one that's identical, 88 joules per gram. And it is by silver, so our unknown metal is potentially silver. And there's our answer for that one. Let's do another one. Compare the energy needed to melt and boil 100 grams of water. So I got two problems on this one. I got Q ml and I got Q ml. So our Q is what we're looking for. We're looking for the energy needed to both melt and boil water. We got 100 grams of water. Latent heat of fusion for water is 334 joules per gram. And latent heat of vaporization for water is 2260 joules per gram. So let's do these quick calculations. So for latent heat of fusion, I got Q equals ml. Q is X, that's what I'm looking for. M is 100. Fusion is 334. So X equals 33,400 joules. So that's how much it would take to melt water if it was in ice form. So now let's do for boiling. So QML. X is what I'm looking for the energy. Mass is still 100. And the latent heat of vaporization is 2260. So X equals 226,000 joules. So to compare those amounts, it requires a great deal more of energy to boil water than it does to melt that water, a significantly greater amount. Last one. How much heat energy would release cooling 24 grams of nitrogen gas into a liquid? So let's set up our given information. So I'm looking for that heat energy again. My mass is 24 grams. And I'm dealing with nitrogen gas going from gas to a liquid, so that's vaporization. So I need vaporization of nitrogen. So here's nitrogen. Under vaporization, we got 200 joules per gram. So our latent heat of vaporization for nitrogen gas is negative 200 joules per gram. Now, why is it negative, you may ask? We are releasing, we're cooling down. Anytime you're cooling down, you're releasing energy, and that's notated with a negative value. Now, in an earlier problem, I didn't include the negative. because we were looking for mass. So this value would come out the same either way because there's not going to be a negative mass. But on this problem, it will matter because we want energy. And if your energy is positive, in this case, it's actually incorrect. It has to be a negative. So let's see what we can figure out now. So I got Q, M, L. Q is X, mass is 24, latent heat of vaporization is negative 200. So 24 times negative 200 gives me negative 4,800. And that's going to be joules. So as we cool down this nitrogen gas from a gas to a liquid, it's going to release almost 5,000 joules of energy. So that's pretty much all there is to latent heat. It's just a 3-variable formula. Make sure you check your units on your latent heat to make sure it matches your energy and your mass. Make sure the temperature doesn't change, or else you're going to have to add specific heat. And just make sure you just practice these problems in general. Eventually this idea is added to specific heat with heat diagrams and heat curves. So make sure you understand this portion too. I hope this video helps, and as always, good luck on your tests.